Puskar and today I'm going to teach you a very important topic of arcs in JEE or NEET both. This is simple harmonic motion. So this is today's topic I'm going to teach you. Simple harmonic motion is a very famous and very interesting topic in physics, and to know this, first we have to know what is the simple harmonic motion is. Simple, all you know about the periodic motion, like something motion of to and fro. You are going somewhere, coming, going, coming, going, coming. This type of motion is called to and fro motion. You all know about this. And something is happening periodically. That's called periodic motion. You all know very much aware of this. Now, simple harmonic motion is a type of periodic motion where the restoring force on a moving object is directly proportional to its displacement from a fixed equilibrium point and is always directed towards the point. A little bit tricky. Let's understand this carefully. It's a type of periodic motion. What does periodic motion mean? It will repeat its motion after some time in a period of time. It will repeat its motion or the path or the restoring force on a moving object. Okay, so let's say is the path x equal to minus a to x equal to plus a. Okay, and this x equal to 0. What is this? This is the mean position of the object or particle, you can say. Okay, so if the particle, let's say initially the particle is here in the mean position. Okay, now you displace the particle x distance from its mean position. Okay, so simple harmonic motion says if when after the displacement the particle or the object will have some restoring force on it, what will be directly proportional to this displacement. Okay, this is the fixed equilibrium point. Okay, so this particle or this object will experience a restoring force towards its mean position on the fixed equilibrium point and always will be directed to this point. Like if this object I replace to here, this point, so the direction of restoring force will be this side. Okay, the object is here, so the force is this side. If the object is here, the force will be that side. Okay, this is the restoring force this object experiences. And the nature of the force is such a way that if we denote this force by F, this is directly proportional to the displacement of the object of the particle. Why this minus sign? This minus sign is because the direction is opposite where the particle moves. I have moved the object this way, right side, but where on the which side the particle experiences the restoring force? Left side. I am moving right side, it experiences force on left side. If I move left side, it will experience force right side. So always the direction is opposite. That's why here this is the minus sign comes. So if you break the proportionality, so what will be this? Here k is a constant. K is a constant. K is a proportionality constant. Okay. So now, as you can see that force is directly proportional to displacement, and we get K as the proportionality constant. Now, from the Newton's laws of motion, you all very much aware of this, that force equals mass times acceleration. You all know about that. Okay, let's put it into this equation. Force is mass times acceleration, which is equal to minus K times the displacement. Okay, so from here what we get, the acceleration is minus K upon M times displacement. Okay, now what is velocity? You know from the vector v equals dx dt. Velocity is the first time derivative of the position. What is the acceleration? Acceleration is first time derivative of the velocity. So it is the second time derivative of velocity. Okay. So acceleration is second time derivative of displacement. Put it into here. Acceleration is second time derivative of displacement, which is equal to minus K upon M times the displacement. You can write in this way. So what we got? We got a differential equation of simple harmonic motion. Just remind it, it's the differential equation form of the simple harmonic motion. Now, if you solve it, after solving this equation, what will you get? You will get, solving this equation, what will you get? It's a second order derivative equation. Okay, you know how to solve it. So after solving, you will get x equal to a cos omega t plus phi. Okay, so here what is x? X is the position, you know, and a is what? A is the amplitude. A means amplitude. A is the maximum amplitude the particle can be displaced from its mean position. What is this? Mean position x equal to 0. This is the maximum position x equal to A. So x equal A is the, here denotes the maximum displacement. Oh, sorry, this is not a cosine function, this is a sine function. So x equal to A means here the maximum displacement possible for the particle from its mean position. Okay. Now t is you know the time here, and phi, what is the phi and what is the omega here? Okay, I have no used omega here. There is no omega, so from where the omega come here? Omega square is the k by m. I have taken this k by m quantity. I have taken let omega square. Okay, so omega square equals k by m. What does it mean? It means omega equals root k upon m. Okay, now so omega is the angular frequency of the simple harmonic motion. Okay. Now you know the angular frequency of simple harmonic motion. Tell me about the time period. What is the formula of time period? Time period is 2 pi by omega. This is the general formula of time period. If you know the angular frequency, you get the time period by this general expression. So let's put it in 2 pi by root k upon m equals 2 pi root m upon k. Okay. Now to get the time period of the simple harmonic motion. Now from here we also can get three other things. So we get the position. Okay, let's once again. I missed. This is the, what is this? Phi. So what is the phi? Here phi denotes the phase. Is the phase factor of the simple harmonic motion. Okay. You know, when you know the particle is performing a simple harmonic motion, but from where the particle started? Do you know about where the particle started? I have told you that the particle was here, now I displaced this. But if I didn't told you, how will you know where the particle started? By putting time equals 0. Here if you put time equals 0, this term will vanish and you will get the position where the particle started the simple harmonic motion. Okay. So like if you, I can also elaborate this with like, if you have a like a pendulum, simple pendulum, its motion can be this to and fro motion. Like if this particle started from here, this is horizontal, this is 0 degree. Like if your particle is started from here, so like this is 30 degree, so then the phase will be 30 degree. If I start the particle from here, the phase will be 90 degree, the phi will be 90 degree. So basically this is the initial phase of the particle where the particle started to SHL. And how can we know that? By putting the time is 0 as the initially the time is 0, then all things started. So by this factor we know that where the particle started to motion. Okay. Now I just want to mention one thing, that if this is the position, you know, I told, if you get the position, if the particle is going back and forth, so it has some velocity. It has some velocity. So how to get the velocity expression? The velocity, if like first we are neglecting the initial phase term. Okay, we are neglecting the initial phase term, assuming that the particle is started from its main position. Okay, so this is the A sin omega t, and you all know how to derivative this. V, what is V? V, what is velocity? Velocity equal to time derivative of position. So it will be A omega cos omega t. Okay. Now you can see, let's break it into this. From this triangle, let's phi equal to 0 the initial phase. So x equal to A sin omega t. X equal to A sin omega t. So from here we can say sin omega t equals x by A. Okay. So this is the angle theta. This is the theta. Sorry. That's omega t equal to theta. Okay. That's omega t equal to theta. So sin theta equals x by a. So if this is the theta angle, okay, sin theta equal to perpendicular x a. So what will be this angle? Sorry, what will be this length? A square minus x square by Pythagoras theorem, you all know. Okay, if sin theta equal to x by a, so what will be cos theta? Cos theta equal to, tell me. Okay, you can derive this. So what we can do, we can write in an explicit way omega improper e square minus x square. Okay, we can do that. Now where the velocity is maximum, the minimum. Now if you see, if you put 0 here, x equals 0, then velocity max equal to plus minus omega a. Okay, and if you put x equals to a or plus minus, x equals plus minus a, then v minimum equals 0. Okay, so at the mean position the velocity will be maximum, and the extreme position the velocity will be minimum and it will be 0. Okay, so at this time, in this closure of time, I can explain. I try to explain the simple harmonic motion with my fist. I can give. So that's it. All about simple harmonic motion this time, in this period of time. Okay, let's see.